Welcome back to The Explainer. I want you to think of yourself today not just as a student, but as a paleontologist. Seriously. When you look at a massive, intimidating Cambridge mathematics past paper question, specifically for syllabus code 0606 additional mathematics, you're looking at fossil layers. Your job is to carefully dig through those question parts, extract the raw data, and reconstruct the full, perfect answer. Today we are taking on one of the absolute beasts of the IGCSE AD math syllabus, velocity vectors and particle collisions. I know. Just hearing the phrase particles colliding strikes fear into the hearts of so many candidates. You sit down, the timer starts, the tension-building music is playing in your head, and panic sets in. But I promise you, by the end of this explainer, you are going to see this not as a nightmare, but as a completely solvable puzzle. We're going to look at the exact strategies the top percentile of students use to crack this code. We're going to reconstruct the full answer layer by layer.
Now, what's really interesting about this slide is that it reveals the absolute secret weapon to unlocking those top-tier marks. This isn't just nice advice from a textbook. This is a direct word-for-word quote derived from the Cambridge Principal Examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. What does that actually mean for you in the exam hall? Well, let's look at two archetypal students we see every single year. First, you have Alex. Alex overloads his answers with raw mathematical facts. He memorizes every vector formula, but he provides absolutely zero cross-topic analysis. He doesn't connect the geometry to the kinematics. Then you have Sam. Sam just rushes. He sees velocity and completely misses the specific command word requirements, calculating speed instead of position. Both Alex and Sam bleed marks, and their papers come back covered in red pen. The examiners are actively looking for candidates who don't just regurgitate formulas, but who see how velocity vectors connect to the broader mathematical universe. That is the true challenge we are tackling today.
To get you operating at that elite level, here is our agenda. First, we'll establish the core principles. Then, we decode the method mark strategy. Next up, examiner warnings. And finally, we will build your winning exam strategy. Okay, let's dive right into Section 1, Core Principles, and building your theoretical architecture.
So look at this definition of connected conceptual understanding. This is where we start transforming those red pen marks into green check marks. Cambridge examiners reward candidates who can transfer fundamental principles, precise mathematical definitions, and causal relationships into completely unfamiliar, context-based problems. Rote memorization literally fails here. When you're faced with a complex, multi-stage situation like two particles, A and B, on a collision course, you can't just plug numbers into a memorized equation and hope for the best. You have to adapt your theoretical knowledge to the specific context of the problem. This requires a structured framework. In essay subjects, they use the Peel framework: point, evidence, explanation, link. Well, we use a modified mathematical Peel framework for this. Point, what is the command word actually asking for? Evidence, what are the initial position and velocity vectors given? Execution, doing the actual cross-topic math. And link, connecting the final numerical answer back to the context. That's the secret sauce. Now, before we continue and look at how this directly applies to cross-topic integration, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Right, let's look at why cross-topic integration is your greatest asset for achieving those top-tier marks. Remember Alex, the student who just throws a bunch of isolated vector equations onto the page? He's missing the integration. Isolating velocity vectors in your mind as just a standalone vector problem is a massive mistake. The theoretical architecture of this topic completely relies on its integration with other syllabus areas. Are you using your kinematics principles? Are you applying geometry, maybe some trigonometry, correctly within that vector space? When you show the examiner that you can integrate these mathematical concepts seamlessly, when you can fluidly move from a position vector equation into solving a quadratic equation for time t, you are demonstrating true mastery. That's how you shift your mark potential from 50% straight up to 100%.
Which brings us to Section 2. Let's shift our focus to the procedural framework. This is the method mark strategy, or how you earn marks for the process itself. The crucial point here is how examiners award marks. They don't just care about that final number at the bottom of the page. Here's a breakdown of the strict procedural conventions you must follow to secure those incredibly valuable method marks. In a multi-stage problem, you are writing a ton of math. Your presentation matters. First, use proper headings. Second, apply correct terminology. If the command word says velocity, do not give a scalar speed. That's exactly where our other student Sam loses his marks, rushing and ignoring the terminology. Third, use appropriate formats. Whether you choose column vectors or IJ notation, keep it consistent. And fourth, provide clear annotation. Walk the examiner through your logic step by step. If you make a tiny arithmetic error at the very end, this exact procedural framework is what guarantees you still walk away with a lion's share of the marks. It acts as a safety net. And a huge part of securing those method marks comes down to how you handle the source data. Look at these data interpretation essentials. Imagine opening your exam paper and seeing a massive, intimidating paragraph about a ship leaving a port at 10 a.m. with a specific velocity vector and a submarine intercepting it. It's a lot, right? Your very first job, the evidence part of our Peel framework, is to extract that data accurately from the text. Then you interpret the complex relationships. How does the position of the ship change over time t relative to the submarine? Finally, you draw evidence-based conclusions to formulate the exact equations needed to find the collision. It's a highly logical, step-by-step extraction process.
So we know the theory and we know the strategy, but to truly bulletproof your exam, we have to look at what not to do. Let's move to section 3, examiner warnings. We are about to do an autopsy on failed examiner answers. Before we do our interactive breakdown of these answers, I need your full attention. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into our interactive workshop. Notice the stark contrast on this slide between a flawed presentation and an examiner-approved one. On the left is what so many students, like Sam, think works: generic, formatless scribbles, rushing to find a collision point without any structure. On the right, we have the examiner-approved version, carefully checked, context-specific formatting. The examiners explicitly state in their reports that practical application in this subject develops professional skills. Your paper needs to look like a disciplined mathematician wrote it. Let's test your eyes right now. Imagine a complex data table on screen detailing 2 intersecting vector paths. You have 60 seconds on the clock in a real exam to scan this. What's the core trend? The core trend is always identifying the initial position versus the rate of change, the velocity. If you can extract that in under a minute, you are already ahead of the curve.
Let's keep this workshop moving. Here are the top 3 mistakes where students literally bleed easy marks sourced directly from the principal examiner reports. Number 1, forgetting to include proper format. Number 2, failing to check that format and presentation. And number 3, the biggest one, providing answers that aren't specific to the given context. Let's play Find the Flaw. If a student writes a paragraph saying, the particles collide at t=4, so the answer is 4, what's the flaw? The examiner commentary tells us exactly what's wrong. They failed to link it back to the context. At t=4, what is the actual position vector? The command word asked for the location of the collision, not just the time. Missing that final step throws away crucial marks. Which leads us to this massive examiner alert. Candidates consistently confuse key terminology. They mix up velocity with speed, position vectors with displacement vectors. So here is your next interactive challenge, speed writing. You have 30 seconds to write one perfect introductory sentence for a collision problem. Go. All right, time's up. The perfect sentence, according to the examiners. Always define your terms before using them. You should have written something like, let vector r be the position of particle A relative to an origin O at time t. This brilliantly simple act clears up your own thinking and explicitly proves to the examiner that you understand the terminology. We've covered a lot of ground. We have the theory, the method, and the warnings. Now it's time to reconstruct the full dinosaur. Welcome to Section 4, your winning exam strategy. Take a mental screenshot of this slide. This is your final execution protocol, your ultimate 5-step checklist, the cheat sheet recap that guarantees top marks if you follow it. Step 1, deconstruct the question. What are the command words telling you? Step 2, extract the relevant data from the noise. Step 3, select your analytical framework. Are we setting position vectors equal to each other? Step 4, execute with absolutely clear notation. Step 5, present the final answer using correct terminology, perfectly tied back to the specific context. This is the complete mathematics answering system. It combines command word decoding, our modified Peel framework application, and proper time management. When you execute this, your mark potential climbs all the way to 100%. Of course, knowing the system is one thing, remembering it under intense exam pressure is another. Here is a brilliant memory hack right from the research directives. Encode these velocity vector concepts using a visual story method. Because particle collisions are inherently visual, don't just stare at abstract numbers. Imagine the story playing out in your mind. Particle A is a ship leaving port. Particle B is a rescue helicopter. Visualize their paths as literal lines intersecting on a map. By turning the mathematical process into a chronological story, from departure to the journey to the point of collision, you encode those causal relationships deeply into your memory. It makes it incredibly easy to recall when the clock is ticking down. Students who implement these exact mathematics strategies, the visual story, the explicit formatting, the data extraction, see an average improvement of 2 whole grade boundaries. But honestly, that only happens if they practice consistently with our weekly videos.
So, I want to leave you with this final provocative thought. If you applied this exact examiner's blueprint to your last past paper attempt, how many more method marks would you uncover? I absolutely guarantee there are points sitting there, hidden in the fossil layers, just waiting for you to dig them out. Get out there, try this structured approach on a multi-stage vector problem today, and watch your confidence soar. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Thanks for joining me on The Explainer, and I will see you next time.